Look at this thing, huh?
I know. This is not what I was expecting.
Okay, back it straight out. Go ahead, put it all the way down, go ahead and reverse, go ahead and back it out.
He's getting used to the throttle though.
That's all right.
Never driven one of these.
That thing zooms.
It does, that was in low. This is gonna be a fun project. Building an exoskeleton for this thing. This is the Blacksburg Rescue Squad UTV, which is it's what these vehicles are. It's a side-by-side. People call them Razors. That's the Polaris version. This, I think, is a Polaris. Yeah, Polaris Ranger XP. They use this for, I'll have Tom tell you, but they use this for like woodland rescue, you know, campers, hikers. Tom, you mind telling the people what you use this thing for? This is Tom Rogers, everybody. Say hi, Tom.
Hi.
What do you guys?
Basically, this is used for any type of rescue that could be out into the woods, could be on trails. It's also used in the town of Blacksburg when we have stepping out or we have football games. This is what we use to work through crowds or to work through the woods or whatever the media may be in which we cannot take a standard vehicle or an ambulance to take the patient and bring the patient out hopefully safely. And what the goal is now is to completely encage this, so if we're off-road and all of a sudden something slips, whatever may happen, if the thing does roll, which I hope it never does, it protects the people in the back. Because right now there is no real protection back here.
Right. You've got one main hoop out of some rectangular tube.
Been bent a couple times.
Yeah, come look at this, Walker. This was, someone caught a tree, huh?
Yeah, we caught a tree.
So this whole side been bent back. Wow. This thing buckled. We tore some welds down here, and that's been
re-welded about 3 times now.
Yeah, so, I think that's about 2 times too many.
Yeah. So the goal is to make it more in the shape of the, you know, the roll cage.
Right.
And minimize the clipping of trees.
Well, the corners will be smoother. It'll be within the existing footprint.
And we're still going to attach it here and here.
Yep.
We're going to buy a 12-inch Star Life, and the rest of the material, the white, we're going to have to buy, but we already have the yellow. And like I said, in case you get careless.
Appreciate that. Woo! Okay. Oh. Dang, those are bright.
Yeah.
Just take care of my girl.
Deposit, I will. What's her name?
It depends on if it's running or not.
Yeah, right.
Well, let me get out of the way. I think this person wasn't happy with me.
Oh, they couldn't get over it. All right, man, thanks. I'll update you. This time on Lift Arc Builds, we built an exoskeleton for a UTV for the Blacksburg Rescue Squad. Yeehaw. All right, so here we are, day 1 on the UTV roll cage project. And I'm gonna start with a little disassembly and some tear down, pull all the stuff off the back of this thing, remove the placards that I need to, start working on pulling the lights out of the rear bar here. We gotta pull these top 4 flashers out and these side flashers out of here. And we'll chase the wiring, all the wiring goes over there to that side. And then we'll cut some stuff off and grind it smooth. We gotta cut all this off here. This is already coming off because of they hit up here with a tree. So that'll come off. The middle divider here is gonna stay, but everything else is gonna come off. This side rail here is gonna come off. And we will make an angle that sits here that will allow our steel cage to interface with the aluminum box because it's got to bolt together. You can't weld aluminum to steel. So yeah, here we go. We're gonna start with some disassembly. got the lights pulled out. Everything was crimped and or soldered, so I'm gonna have to cut these wires and then solder them back together later. It's no big deal. We've got a circuit that runs these side flashers, and then we've got a circuit that runs these rear flashers. Looks like they were ready to add another light here, but they didn't. No grommet to protect the edge of these sharp holes, so that's interesting. This is how they did it. But we'll get the lights yanked out and coiled up over there, and then we'll cut this thing off. So I found some 2-inch angle in the rack, and this is the plan as of yet. This one actually fits perfect. I don't even have to cut it. But because there's doors right here, we're gonna let this angle sit up like that, leaving this web of the angle here versus just doing a flat bar. We'll add some strength. And this is where the stretcher slides, so if anything, it can maybe act as a guide as the stretcher slides in here. So that'll be nice. And then our tubes for the cage will sit here and be welded right there. On this side, we don't have compartments, so we can flip the angle down and weld our tubes here. And these angles will be bolted to the box. So we'll through bolt in a few locations, and that will give us a steel base that we can start fabricating our steel cage from. But yeah, everything's stripped down. Got all the old stuff off. Looks good. This guy here was welded to the upright. So we're gonna use one of those bends and cut this back and return it back down to the bed here. Because this is where they clip on the top of the basket here. So this has to stay. We'll just take that elbow and kill it right here. Cut this back. I'll probably do that first while there's nothing in the way. But I'm gonna clean these guys up. I'm gonna weld shut the holes that are here from whatever this was used for last, and then figure out where to make our holes for bolting. Figure out if we're gonna have an issue in here. Nah, we'd be all right. There's enough space for a bolt to live in there. Onward. So there are base plates. Just went ahead and did a nice little chamfer at the end, clean it up. That one's gonna live there, and then this one's gonna live right here. Cut it to contour match that slope, wire wheeled it, cleaned it up. It's ready to weld to. Pretty close getting these on. Once these are on, it's time to shift gears and do some tube bending. Start laying out our main hoop. Good progress. Slow but sure, want to get everything right the first time. Okay, quick update. The end of the day, it's a Friday, so I'm probably done here, but it's what we got. So we got 2-inch angle bolted to both sides. This side, the angle's up. I had to push these fasteners back from the midline because I had to dodge some stuff that's under here, but I got all 6 of the fasteners to connect and be bolted down. So this is for sure not going anywhere. They might as well consider that part of the structure now. And so I'll have the front hoop is gonna be here, and then 36 inches back, the rear hoop's gonna be here, and those are 2 main hoops like you would have in a normal car roll cage. And then here's an intermediate vertical that'll be solid panel here, expanded metal over here. So I got all that mapped out, everything's looking good. And then on this side, we got the same deal. We got 3 bolts in the top, 2 bolts in the side. The angle is down because I didn't have anything in my way. And we'll have the rear hoop here and the front hoop here. So now I've got a steel foundation onto which I can build my steel roll cage that all bolts to the aluminum bed. You can't really see a difference right now, but that was a lot of valuable prep work. So now we can just start motoring. Next week, I will be mapping out my hoops, setting up my bender, and hopefully not wasting a bunch of material bending it wrong. But I have yet to do a main hoop. I've done 2 roll cages, but I bent everything except the main hoops because I got those pre-bent. I know how to do it. I know the math. I know how to measure it. I've just never done it. So I'm gonna bring you guys along for the ride. Time for the weekend. See you on Monday. All right, hello everyone. Update on the UTV roll cage build before I get stuck into it here and start bending some tube. I've got a few things to figure out. So these are the drawings that Tom so generously created. We've got driver's side view, passenger side view, top view, and back view. So it's helping me. I'm using this to take notes, and I'm also drawing my own stuff. So here is a drawing of the tube that's gonna be right up against the back of the cab. And then back here, 36 inches back, we're gonna have a tube that's taller than the main hoop, which will allow us to do this. So we'll have our front hoop here. If you imagine the cab's right here, the front hoop's here, and then the top bars go up and back to a taller rear hoop. So I think geometry-wise, I'm gonna do the same, just the rear hoop will have longer legs. But we're not gonna do a perfect square. We're gonna you do like an 80-degree bend here, and then it'll be slanted until about here, and then it'll do the rest of the 10 degrees and come back in, which is sort of pictured here. You can see how it comes down, it's still slanted, and then a little bend here that straightens out the leg. That is to keep the top corners of the cage inside the boundaries of the cab, because with the last one, they were having issues where these corners were sticking out past, and when they're going through the woods, trees and things, you can see where trees, like they use this thing. There's rub marks and everything. So tree branches would be going down here, and then they'd catch the main hoop. So we're gonna keep the main hoop inside the footprint of the cab here. Yeah, so this is a trick I learned from Justin over at the Fabrication series on YouTube. Put tape at critical points on your chassis to mark. It helps you measure things out. I'm using a JD Squared Model 32 tube bender today. I've got my 1.5 inch die loaded up. It's like a 6.5 inch centerline radius. And a long time ago, I bent this 90 with this die, and I marked that cut right there corresponds to the front edge of this die, which is a nice measuring spot. So the reason I did that is I can take this 90 and hold it up to sort of simulate where I want my bends to be, and I can transfer a mark from that line to the chassis, and now I know where to measure, where my bend stops and the straight starts. That's essentially what that line is illustrating for me. The easiest way to do a main hoop is to start from the center and work out symmetrically. So when I cut some of my raw material, I'll work up a total raw cut length based on all these measurements. And then I'll start in the middle and bend outward like this. You make this bend straight, make this bend. I fully realize that this is a lot of information. So I'm trying to give you the technicals if you're curious about the technicals. So at the risk of over-explaining things, I'm gonna get started. I'll try to explain as I go. But really, figure out your raw length, mark your midpoint, all your bend locations, and then just start bending incrementally. You know, leave a little extra on the ends so you can trim it and fit. I did a bunch of measuring yesterday. I think I'm ready to start cutting. I may go lay something out in CAD real quick just for peace of mind, but that will only take like 20 minutes. Let's get to do a few more double checks and then we're gonna get to cutting. Okay, so there is software out there specifically for designing roll cages. I believe it's called BendTech, but I just want to do a 2D layout just to double check some things. So I'm gonna fire up Fusion and just do a 2D drawing of this here. Just establish some constants and make sure like my angles and everything makes sense. I know my bend radius and all that, so we will see. It's a 6.5 inch centerline radius. And I've got some measurements here. This is my roof line here. So this is the bed down here. And now I'm making my roof line. So now we can establish our boundaries. Just going in here and assigning some dimensions. So it looks like, you know, we want this to be 90. So with these two angles, it shows us what we need to do. So we can, you know, as long as from the top horizontal to the side piece equals 90, we can divide that in two pieces however we want. We could do a 95-degree bend and then a 5-degree bend. We could do a 90 and a 10. I'm kind of leaning more towards a 90 and a 10, but I think I'm gonna lay this out on the table and see, mark my straights, something of that sort. The one thing this doesn't exactly help with is start of my bends and end of my bends, but I can translate that somehow. So I'm gonna print this. I'm gonna print this out. I'm just trying to be extra careful because this is the first main hoop I've built from scratch, and I want to get it right. I'm trying to use all the knowledge I've soaked up on YouTube and from other people, think it all the way through. So let's go back out in the shop and do some more thinking. All right, so here's where we're at. A lot of thinking, and now I gotta download this thinking into you guys. So I've mapped out my limits, so I know how high, the vertical height that I can't go past, and then where my top corners are gonna be here. I measured the top width of the top of the cab because I don't want my corners to poke out past that. So we establish our constraints first, and then using this bendicator, clever name for this tool, also by JD Squared. This bendicator is matched with my die on my bender over there, sorry. And so I can use this. I've marked out where my bend starts are based on this mark here. And so I can use this to play with the angle and see where it's gonna telegraph my tubes. So I want it to be within a certain width up top, but I want it to get wider down here, and I mapped out where I want it to land. So I can use this guy to put my corner in the right spot, but based on the angle, it'll push this leg in different spots, and I can see where that makes the tube end up. So essentially, I've landed on 80-degree bends here. I know where my start of the bends are, and I know where my midpoint is. So I'm gonna cut a rough piece of tubing, mark my midpoint, make two 80-degree bends this way and that way, and then I'll lay it up on here and double check everything before I commit to the 10-degree bends that will be down here, because 80 plus 10 equals 90, and that'll get me where I need it to be down here. That makes sense? You follow, Steve?
Oh yeah.
Oh yeah.
80 plus 90.
80 plus 10 equals 90. Don't do that to me. Okay, so I'm gonna go calculate a rough cut length for my raw material based on my 3 legs. And then I'm gonna cut it long, and then we'll start bending. All right, so now we gotta lay out our pipe. So I'm gonna find the midpoint first. Now from that midpoint, I measure out to the start of my bend. So I need to figure out what that is based on my template. So 19 3/4 is the distance from the midpoint to the start of the bend. So I'm gonna mark that now. All right, so we're ready to bend. First bend. Let's see how wrong it can go. All right, so here's this 280 degrees. And so what Steve and I were just talking about is essentially, it's gonna be near impossible to show, but essentially the edge of that wooden board is my outer bounds. So really, I'm gonna keep this straight section parallel with the pipe below it and ride it up the pipe like so until the gap between my elbow and the edge of the wood is what I want. You know, there it's touching, on up, there's a little less. So I'm gonna shoot for 1/2 inch on each side to bring it in. I think that'll work. All right, so we're close enough for the job at hand. So I'm gonna cut my legs down now. This one's gonna get cut here, and this one's gonna get cut here. And then we'll go test fit it, and then one hoop done. Took a while, but I wanted to be really careful. I have a lot more confidence now going into this, and the second one should happen a lot faster. Another day, another dollar. We got the second tube bent up, at least the initial, and now I'm mapping out the second bend to bring the 85 degrees around to the 90. So we just need 2 5-degree bends lower. This one's been a little tough to get right in its own way because the way these are drawn, you have the low hoop and the high hoop, and the slanted members occupy the same plane. So I had to extend the lines here on up so you can see where the old tube was and where this one is, and this diagonal is on the same plane. So now I'm just trying to figure out where to make that bend so that it can line up sort of with the other one. But yeah, just doing a little more thinking, and then 2 more bends, and then we'll mock this one up on the UTV. And then once the main hoops are in, then the rest of it gets a lot easier because we're just cutting pipes, notching pipes. Most of them are straight connector pieces, except for the top ones. The top ones are gonna have this curve here, so it's gonna go straight and then curve down and be notched. But there's only 3 of those, and that's pretty easy to figure out. Because then we got straight here, straight here, straight, 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 straight. Yeah. So we're good, and then I've got the material ordered. I've got the expanded metal ordered, that'll be here tomorrow. I've got the 1-inch tube ordered, that'll be here tomorrow, and then mounting all the lights and stuff will just be a matter of making tabs and brackets and things and cutting them out on the plasma cutter and fitting them. So let's finish this tube, enough talking, let's do it. So we might be in a little bit of trouble because it's kind of hard to figure out. I'm sure a bunch of you out there watching already know that I did something wrong or know what's wrong with this. But we've got this sort of double curve, right? We've got on the front hoop, we've got 80-degree curve and then the remaining 10-degree. And I made sure that the bend, this part stays straight because of how this basket needs to fit in, 7 1/4 inches up. So I wanted this all to be straight. This back hoop is taller, right? So the bends aren't gonna happen in the right place. And I thought I'd map this out correctly, but if you look, that bend and that bend don't happen in the same place. and that's completely my fault. This bend, I thought I measured this. This bend starts 12 1/4 up. This bend starts 7 1/2 up. So now I'm at a crossroads where do I deal with this? Do I leave it? Or do I make another hoop? I've got 2 more bars, and I think I'll still have plenty of material to do all my connectors. These are why main hoops scare me, because it's a lot of material, and if you get it wrong, it's kind of trash.
And hopefully not wasting a bunch of material bending it wrong.
Although, you know, I'll be able to reuse that top straight section and whatnot. So I either rebend the back one or I cut the front one off and rebend that. I guess it depends on bend position. I think I'd rather have the first 8 1/2 inches straight versus this one. So unfortunately, I think I'm gonna have to remake that just because I want these bends to be at the same height, and I gotta figure out what I did wrong. We're gonna have connecting pieces running forward and back. Therefore, these things need to be sitting at the same angle. How do I get the rear hoop to have the same geometry as the front hoop, but sit higher like this one does? I'm gonna need to think on this. My brain kind of hurts, and with the camera rolling, I don't have full access to my thoughts, so I'm gonna put you guys down. I think I know where I messed up. So on the front hoop, those bends are 85 degrees. The rear one, they're 80, because by extending this up, I thought I needed, or sorry, it's 80 on the front, and these back ones were 85. I thought I needed less flare out because this thing's taller. But what I need to do is actually do the rear bar just like the front. So 80 in the corners and 10 down here. But to make it taller, the straight section in between these 2 bends is where I get my height. And as I increase this straight distance, the flat horizontal needs to shrink, because as these telegraph up at 2 different angles, the bends become closer together. So I think that's the move, is essentially remake the front bar. I'm gonna go draw this in CAD again, I think, because I've already drawn the front bar in CAD, and I just need to raise the height a certain amount, which will gain from those straight sections, and then this top horizontal will shrink to account for everything moving up. And that way, these bends, these subtle bends here, will be in the same place, which is important because we got horizontal going across here. Okay, I was probably rushing yesterday, and that's what you get when you rush. So I've officially made my first piece of scrap metal. Luckily, I ordered 4 sticks of this stuff. Plus, I think I've got another stick back here. Yes, another piece there. Anyway, back to the computer to figure this out. Okay, so this is an interesting comparison. This hoop on the right was drawn using the same parameters as the hoop on the left, except that the top horizontal ends up 5 inches higher. And what I was curious to see, I kind of guessed. So over here, I inset these circles 8 inches, these 7 1/4 radius circles. I inset them from this sample box to achieve that sort of slope that we're after. So over here, I was guessing, you know, we want the bends at this location to be the same height, which they are, and we want the angle of this member here to be the same as this one here. And so if I measure the original one, we have a 94-degree angle, but over here we have 94.6, so it's close enough. So what this tells me, roughly, as far as the dimensions go, I'm so sorry that I'm speaking in a really broken, slow, stuttery way. I'm thinking this through as I present it to you, and maybe I should have thought it through more before I present to you, but this is the reality. So essentially, I've pushed these bends here closer, an inch closer together, in order to account for the fact that by extending this straight member, this top piece needs to shrink. So essentially, by the way I've dimensioned these compared to this side, I've lost an inch off the top. And I wonder if I change this now, will everything go with it? Yeah, So I think that should work. So really, if I do the exact same thing I did for this, but shrink this horizontal member by 1 inch and then lay it on there and telegraph everything that way, I should be good. I hope that made sense to you. It barely makes sense to me, but I'm working my way through this. And if I do more of this, it might be worth investing in like a bending CAD software or just being better. So I'm gonna let this marinate and stare at it for a little longer, and we'll go back out in the shop and put the plan into action. Everybody, here we are. My buddy Jake Freeland is over here at the shop. You'll be seeing more of him. He's gonna come do some work out of this shop for his business, Freeland Welding, and we're joining forces. But anyway, he's here hanging out. You don't have anything better to do, I guess. No. But so here we are. We've tested the rear bar, and I'm much happier with this one. You can see the bends are in the same place, left and right, and we're 5 inches taller. It's level. And the space between the front and rear bar is the same no matter where you measure it. So everything's tacked in, super pleased, and now I can start working on horizontals. I think the next hardest thing to do is gonna be the top bars, which are this shape. Straight and then a bend down. I gotta map that out somehow. But that's what's next. All right, here's what we did to bring you guys along. Again, we're making this roof section here that the bar is straight for a bit and then a 45-degree bend, and then it comes in and bird's mouths into the front hoop and the rear hoop. So what I did was draw this in real time. So we located one tube here, 5 inches up, and then one tube here, essentially a 0 point. And we will have our tube go straight, and then using the bendicator, we figured that this was a 45-degree angle, so we set this at 45 and essentially put this on our tube line and situated it to where it intersects with the other tube we drew. So then we have 25 and a half inches of straight, and then our bend happens right there. We bend at 45, and then the rest of it runs into here, and we trim it and notch it. Make sense? Sorry if it doesn't. Watch how we do it. Notch master from JD Squared. So now we pretty much line this up to where it's halfway across the bit, and then we go to town. And there you go, a perfectly coped tube. Right tool for the right job.
When you're filming Tay, you have to lift your arm up high.
Close enough. Okay. Tension, make sure we're at 0. Let's start cruising. Hope I don't run out of pipe. That's it or not. 45 degrees. All things being equal, should be able to set it in here, lower it down. We're actually a little past it, which is fine. That means I can just re-drill that and bring it back here. All right, and there's the result of all that math. Fits great. It's a hair short, but it could be that this tube is just out. So very pleased with that. All the geometry looks like it should. And there's gonna be 3 of those. So those will snap up quick, and yeah, now this thing's really starting to take shape. Really starting to look like a cage. The back hoop fits great, looks really good, looks the same as the front hoop. Very, very pleased with this. So I know I keep saying this, but tomorrow this thing is gonna take shape. All the parts, the rest of the metal shows up. All the hard stuff now is done, so we're gonna start welding some tubes together tomorrow. Yeehaw, see you then. Quick update before the battery dies here. Got the 3 roof bars tacked in. We got all our base of the main hoops welded fully, and I'm very pleased with how it looks. It looks good from the front, looks good from the back. No glaring issues yet. Everything's vertical that should be vertical, square that should be square. So now I'm gonna do 2 horizontal bars this way. We'll do a low bar, split one in the middle. Yeah, this thing's coming together. Status report, we've got our 2 chop horizontals mounted, and I need to make an intermediate bar here. So I'm gonna mimic this exact profile here. So I left my mark on from when I originally bent it, so I know where the bend will start. So it's 9.5, 10-degree bend, whatever that is, and notch it to go around here and kill right into that, because we'll have expanded metal in this half and a steel plate on this half, and same over here. So actually over here, this horizontal that I have not welded in yet probably won't be there. I'm gonna have to do the same thing, one that goes down like this of sorts. So that's what I'm cutting out. Go bend this 10 degrees. Looking good. There's the next intermediate bar. All those bends line up and happen at the exact same place. Real satisfying. So we'll weld that one in. It'll be 2 square bars instead of this continuous length square bar. There'll be now 2. So one here, one here. So I'm gonna split that one in half, mount it in here, and then this side is done and ready for plates and expanded metal. All right, so slight change of plans. On either side of this thing, in this opening here, it'll be bifurcated, and the front half will have a solid plate in it that they will vinyl with that 6-sided EMS asterisk looking logo and some reflective tape, and then this back half will be expanded metal. So instead of this piece in here like that may go back in later, but I think the first thing I want to do is make this vertical, and then if we want a horizontal in afterwards, we can just do it in 2 halves. I'll do what I just did on the other side, take some measurements here. We got 9 inches from the midpoint here to our beginning of the bend. So, and then below that I've got 24 inches. Yeah, so we're real close to finishing up the structure of this cage here. Once the main hoops were done, the rest of it's been really fun. Just sort of minor bends, mostly notching and measuring. And yeah, it looks pretty badass. It looks definitely, it's gonna be super safe and quite striking to see it all together. And once it's powder coated and everything, it'll be cool. We're still debating on a diagonal coming down this back area here. But other than that, it's pretty all right. So anyway, it's Friday here at the shop. It is 5 till 5, and I think that's a good stopping point. I'm gonna come probably mess with it a little bit this weekend, and Tom's gonna come on Monday to check the progress and you know, give me the go-ahead to keep going. I have some questions for him anyway as far as placement of things. So yeah, thanks for watching. I'll see you in a bit. Bye. All right, what's up everybody? We are back on the UTV. I mean, I've been on the UTV, but I got a next chapter. So I am designing right now all the panels. The panels that are gonna fill in the gaps between the tubes on the sides of the roll cage. And I was here till about 8 last night, drafting up some of them, and I'm gonna bring you guys through the process to make something like this. So this is the panel on the driver's side front. The hole in it is for this light right here. There's one of these on each side at the front top corner of the cage. And then this lattice work is what the customer wants, and we're gonna CNC cut these panels with holes to be bolted using these tabs right here. Come on, camera. Hello, there we go. These tabs right here. That'll be welded to the pipe and then go into corresponding holes. You can see the plan here. Here's the driver's side rear panel. I've already got the holes and stuff laid out. The holes aren't spaced evenly because I wanted them to go into specific spots, because it's gonna have to be bent to follow the contour of the cage, and I don't want the hole to land on a bend, so I had to move them around. Anyway, so I learned a pretty cool trick in Fusion if you want to do something like this. So I'm gonna do this panel with you so you can see now that I've learned. So I've measured my openings and I'm accounting for my margins now. So my openings, 15.5, I subtract a 1/2 inch, that's a 1/4 inch on either side. So 15 wide by 32 3/8 minus a 1/2 is 31 7/8. All right, so we've got our rectangle. That's the outer limit of the panel. And now I'm going to offset the border inward by 1 inch. And that's our margin where there's no lattice work. And that's to give strength and to be where all the holes go. All right, so we want this, we also need to plot out, this one's gonna have a light in it. So I'm gonna delete this line, I'm gonna delete this line. I'm gonna make an overall slot, and I've measured my hole, the gasket here on the back of the light. And it is 6 5/8 long by 2.475 tall. And now I'm gonna space that off the wall 1 inch here, and then dimension this off the wall 1 inch as well, okay? And then we'll take lines and we'll finish our border like that. And now we're gonna offset this 0.375 or 3/8, and we're gonna trim what goes outside this border here and open it up like that. So now we've got this solid piece like that. That's all gonna be metal, and then inside of that is gonna be lattice. All right, so here's what you do. You finish the sketch, and then you go to extrude. All right, I extrude the outside first. This is gonna be 1/8 inch metal. This isn't really relevant to the plasma cutting process, but it's how I do it in Fusion. All right, so you've made an extrusion based on a sketch, so the sketch went away. So we'll make the sketch visible again. And now we'll click this interior body and extrude that as well. And you wanna make sure that when you extrude, I'm extruding the same thickness, but you go over here and say new body. So now we've got 2 different bodies. It's all the same piece, but they're over here under bodies. You have body 1, which is that one, and body 2, which is that one. The reason that's important will be made apparent in a minute. So now we create a new sketch in body 2, and I'm going to center a diamond in this square. So I'm going to draw 2 lines at the midpoint, give me my center. And I'm gonna create a center point rectangle that's 1.5 by 1.5. All right, and I'm gonna select it, and I'm gonna go to move, and I'm gonna pivot it 45 degrees. And then here's the crucial part. You need to make 2 lines, at least for this pattern, that will be the axis along which the pattern is created. Okay, so I've made 2 little 45-degree lines there. I'm gonna finish the sketch. I'm gonna delete my midpoint lines, and I'm gonna extrude this through to cut. Okay, so I've cut my diamond hole in the middle of the panel. Now we need to make a pattern with that extrusion, with extruded hole, to make all the other holes. So here's where the magic happens. You go to rectangular pattern, you change this to features, and now I can select a feature from the timeline. So I select the extrusion that made the cut, and then I go to axes, I make this sketch visible, and I pick this axis and this axis. All right, and I've measured my spacing. So you just bump the quantity up big enough to where they'll go past. My spacing is 1.875, and then 20 here, and 1.875. And what that should do, symmetric spacing. Let me try that again. Rectangular pattern, features, object is this, axes are this and this. We'll be doing spacing, 20, 1.875, 20, 1.875. And now if we do symmetric, okay? I know that looks crazy right there, but that's filling in. And watch this, when I hit OK, computing, I'm loading up my computer right now. Boom, look at that. So because the sketch I made that center hole with was exclusive to that second body, the interior body, the pattern I created didn't go any further than the extents of that body. How cool is that? Really stoked on that trick. So yeah, now to turn this into a DXF, you know, I still need to do my holes around the outside, but to turn this to a DXF, you create a sketch anywhere on this face, all right? You hit P for project, and you click this body, and you click this body, and you hit OK. But essentially, that's how you can create a sketch based on a three-dimensional model that doesn't already have a sketch. And then the fundamental is, once you've created that sketch, you save it as a DXF, save, and then we'll open up en route, our panel, and look at that. This is a 2-scale DXF file created from a 3-dimensional model that was created from a series of sketches and extrusion methods. So there you go. That is how I'm going to be creating my panels for the roll cage. And like I said, I've already done a few, but that saved me a lot of time, because the very first one I did was this one, and I drew everything from scratch. And by that I mean I drew a line from this corner to this corner, and then offset that 3/8, and then spaced down. And I drew every single line and trimmed all the intersections by hand, and that took about 30 minutes. Whereas you saw I just, how long have we been rolling on this clip? 11 minutes. So cut the time in half. And for the bigger panel, it would have taken me an hour drawing them all manually, because it's literally 3 times the pieces. So anyway, yeah, that's where we're at. So I'm gonna keep rolling on this and knock through the rest of these panels. Then we'll load some 1/8" steel on the cutter. We'll cut out a small panel. We'll probably cut out this one first, because it's nice and small. And then we'll verify that my inset for the holes works with these tabs. I just want to be able to bolt these tabs onto the panels and then hold the panel in the gap and tack the tabs where they land. And I'm gonna use 1/4" fasteners, and my holes are 0.3 or a little under 0.3. Quarter is 0.25. So I've got a little slop, and that way these tabs can move around and find their home. I need to order some hardware. I need to order some stainless hardware from McMaster-Carr for this and for some other things. So I'm gonna time lapse the rest of this, and then we'll throw some metal on the cutter. But hope you enjoyed that little tip. Let's keep going. I'm gonna go ahead and cut this panel here, small one, to a test. I've got a big sheet of 1/8 inch over there, but I've got enough here to do that one. So we're gonna cut it, and what that'll tell me is how rigid these panels are in 1/8 inch, and if my tolerances are right. And this small one, well, it's small, so there's a lot less to lose. So let's try that. Beautiful. Man, it has been a busy week. So it's Friday night at 6:30. I'm gonna work another few hours, and I'm probably gonna come in on Sunday because I'd like for this thing to be ready to go to the powder coater first of next week. We've got our panels having been cut. Got all these over here, cut out, ready to go. I gotta bend them, you know, so where that bend in the cage happens right there, I'd like to bend all the panels to follow that contour. I don't know that we'll do that with this brake, or just kind of putting them on hanging them off the edge of the table, you know, and heating along a line and then just pushing them over. But I'm using my Everlast TIG and coming over all the joints and welding them fully. Trying to keep it clean. I like TIG welding pipe just because it's really satisfying, and it looks good when it's all done. So fully welding all this, and then panels go in, and then roof panel goes on. I think I've already probably said this to camera a few times, but you know, got to make brackets for the lights, so I'll do some CAD work on Sunday and develop those. And then a shelf. So there's a lot that was added. The customer added some things, added a shelf for a defibrillator, which will sit right in here this way. Added the roof panel and added these plasma cut panels as opposed to the expanded metal that was the plan before. That's okay, change orders happen. It's, you know, it's more money toward the shop, but it's more work we gotta do. But it'll look really cool when it's done. These panels, these panels are gonna be pretty trick. You can see that. There's a margin all around, you know, that'll be evened out, but really stoked on how those came out. Hopefully my tab mounting system works out. But anyway, I'm gonna keep welding. Just wanted to, you know, when there's a bunch of other people in the shop making noise, it's hard to pull the camera up and talk to you guys and let you know what's going on. So yeah, anyway, speaking of talking, that's quite enough of it. Let's get back to work. Do you want to go home? You want to go home so bad. I know, but I just fed you. What is this on your nose? All right, what's up, nerds? I made these spacers to help me locate these panels. So basically, 1/2 inch plus 1/8 equals 5/8. And that basically positions an imaginary plane right inside. So basically I clamp, all my gaps are the same. So if I clamp two of these bars in any location where a panel has to go, and then bump the panel up against it, it'll locate the panel perfectly. I'll get them clamped in and you can see what I'm talking about. That will locate the panel in the right spot. And then I just gotta space it side to side. So with those pieces in, I basically push the panel up to it. You can see in here, I've got angle, 1/8 inch, 1/2 inch. And so clamping these across the tube, like here's my math, you know what I mean? 2 tubes, 1/8 inch piece, I want it to be centered. So that line there under the circles represents this piece of angle. And I worked out the spacing that I want, 11/16. I pulled a 16th off just to make it easier to do, 5/8. So these things are spacing the face of the panel 5/8 away from the front of this tube here. Meaning I clamp these on, I push the panel up to it. I know that that panel is located directly at the midpoint or thereabouts on this tube, and now I can tack it in because this one I've already got my tabs bolted in place. So I can tack them in and then unbolt the panel, and the tabs will still be there and they'll be located in the right spot. Make sense? Good. Okay, we finally have the side panels in, and boy, do they look cool. Quite pleased with how they've come out. All the tabs are fully welded on one side. This side's got the full length side panels coming together. That's a big hurdle out of the way. I know I haven't been narrating a whole lot as of lately, just because I'm under pressure to get it done. Trying to knock it out, trying to stay focused. Just trying to set up the cameras and get right into work. So this thing has to be done today, hell or high water. Not only for my own purpose, but for you guys. All that's left is making light brackets on this top rail for these reflectors, these guys, these, something like that. I'll make a custom enclosure for those. These guys go in those holes, doink. I've got to build a shelf for the AED defibrillator thing up here, and I've got 2 more of these bins to put right here that will then give me a mounting surface for the roof panel. So the roof panel I will do last, just because it will fully enclose everything. I also need to weld some conduit up in here and along and figure out the path for all the wiring for the lights. You know, it sounds like a lot. I guess it kind of is, but it's all right. Customer's coming tomorrow to give the final okay before it goes to the powder coater. Therefore, I want to have it finished tonight. Oh, I also we also got to do some tabs to incorporate these cab mounts to the cage. So I was playing around in Fusion this morning, cutting some plates. I think I'll do something of that sort there. I've got my 2 bolt holes mapped out. And so I'll just put a slight bend in that and cut this back to where it intercepts the tube like that. Do one there, one there. I'll just make the plate touch the tube by bending it. And then I haven't checked this side, but we're after the same thing. So that one can just be cut down so that it sits flush like so, and then same thing up here. So that's a nice size. I cut 2 of these out already. I'm gonna cut 2 more. And then that one front corner up there will have a bump out with a circle so that this carabiner on the Stokes basket has somewhere to click into. That's not gonna make sense until you see it. So yeah, this process of bolting the tabs to the panel first, and then really wrenching them down so they don't move, and then test fitting the panel and sanding off, grinding off material from the tabs until the panel slips right in. Worked really well. I got faster and faster at it as I did it, and my welds got better. I TIG welded it, and the beauty of a TIG welder is that you can weld in really tight, confined spaces. I didn't want to weld the panel to the tube. I wanted to weld the tab to the tube, but the tab's bolted to the panel, so I only had little tiny gaps to weld in. And I was running a little extra stick out, running a gas lens so I could have some stick out on my tungsten, and I could feed that right in there and get real close. So anyway, onward and upward. I think next thing I'll do is make these radiuses here. Again, just like that, but right here. So let's do that. New welder day for Jake here at the shop. Look at that thing.
Pretty good too.
Hell yeah. I'll make you a deal on that rack, $4.99.
Okay, deal.
So what do you get for your $4,500? You got
MIG stick, AC/DC tube.
Got you a MIG gun.
Yeah.
You're gonna go Tweako style though.
The shitty new Miller. Actually, I had never seen that one. That's not the same one.
It doesn't look bad. It's like mine, just a little smaller. Mine's like the heavier duty one.
We may have to go Tweako. We'll see.
I don't know, man. If it ain't broke, don't fix it.
I don't know. I like Tweako so much more.
You always keep that as a
I do
backup.
kind of like the ergonomics of it.
Yeah, it's a little more bent. Well, it's about the same. I've been wanting to play with one of these for a long time. I want to see if it's, because it'll do a lot of automatic thinking for you. I want to see how close it'll do, how good it is on aluminum AC TIG.
Yeah.
Because I've spent months, almost a year now, really fine tuning my settings on that machine, which is all manual. I want to see what it does when you just go 1/8 inch aluminum and this size electrode and this kind of gas. Go.
Yeah.
and see what it comes up with.
Who knows? Like their 255 has the same kind of deal, but
The auto set.
that shit never worked.
Right. Well, howdy. Oh, here it shows you how to use everything. All right, I gotta quit getting distracted. I'm gonna get back to work. It's so fucking close. Just fit. Yeah, it's filming right now. Doesn't fit yet. Bleep that out, Walker. You already are. That only took 2 hours. All right, viewers, well, that's what I've been trying to get right for the past hour and a half, is this curve here. Because the roof plate is gonna need 2 radii to come down and weld to. So the only opening we'll have is this area right here. This will be covered with a panel across the top, over the front, and then same over there in between those 2 pieces. So I'm gonna make sure these 2 are the same distance forward from the main hoop, tack those in, double check my measurements for the roof panel, and then we'll load a 14 gauge sheet on the plasma cutter, draw that up in CAD, cut that out. Although, before I do that, I'm gonna evaluate the shelf situation here for the AED, the defibrillator. It'll live right here, full length shelf. Wanted to get all this other stuff in, all the stuff that I know I needed, so that now all the structure exists and I know where I can tack to and support from, or something like that. All right. I'm about to misuse my bender. So what is happening here is this piece normally clamps in the pipe, but we're not using pipe. So I've had to put some spacers underneath, put some spacers on top, put a spacer here, and put a spacer here to keep that collar in the right spot. Because if it moves up and down, it might tilt the tube this way. And now we will lock this down. Doesn't like it, doesn't like it, doesn't like it.